Mass remains constant, but weight vanishes instantly when gravitational acceleration drops to zero. Even without weight, that 1,500-kilogram car still requires massive force to change its velocity. Newton's first law dictates that our bodies maintain their state of motion at second zero. We do not fly off because of our initial velocity and the Earth's rotation. The ground leaves us because it follows the Earth's curvature, not because we rise. At the equator, our 465 meter per second tangential velocity is the key factor. We calculate the gap using this formula for 10 seconds of movement at the equator. At the poles, our tangential velocity is much lower, changing our drift significantly compared to equator. If running at 5 meters per second, when gravity hits zero, our motion state changes abruptly. Static friction disappears instantly, making it impossible to take a normal step forward. Inertia persists without gravity, shown here by 3 examples of continued object motion. Loss of gravity does not mean loss of all other acting physical forces. Remember that. Without gravity, that bowling ball would move in a straight line instead of rolling. Ignoring air resistance, our 10-second path is a straight line due to persistent inertia. The 6,371,000 meter radius is vital for our drift calculations. When the ground's normal force drops to zero, the impact on our skeletal structure is immense. A person jumping during the shift has a much different trajectory than someone standing still. Sudden weightlessness renders standard balance scales completely ineffective for measuring any mass at all. We analyze the kinetic energy of an object moving freely in this temporary zero-gravity state. The Earth's curvature and inertia create an illusion that makes us feel like we're flying. Our atmosphere does not vanish instantly. It persists due to lingering molecular inertia during these seconds. Nitrogen and oxygen molecules begin to expand outward as gravity no longer holds them close. Atmospheric pressure drops rapidly, following a specific rate over these short 10 seconds of change. Molecules collide chaotically, escaping from the higher atmosphere layers first as the pressure gradient fails. Human lungs struggle as the surrounding air expands too quickly for the respiratory system to handle. The oceans do not simply float, they bulge and become chaotic as gravity's grip is released. Major currents like the Gulf Stream lose their path as the ocean's foundation drifts away. Ocean waves lose their restoring force, leading to a strange and unpredictable behavioral collapse. Water in lakes and pools begins to drift upward in a chaotic, bubbling mass. Pop, pop! Watch the amazing bubbles rise. Pop, pop! They're like little wonders. Pop! Archimedes' buoyancy principle becomes completely invalid because the acceleration of gravity hits zero here. Cumulus clouds deform rapidly as atmospheric pressure shifts in this strange new environment. Inertial tsunamis may arise along the eastern coasts due to the Earth's rotational momentum. Tropical storm structures distort drastically, losing their orderly rotation in the next 10 seconds. Ocean evaporation spikes as the sudden drop in atmospheric pressure accelerates the liquid transition. Bubbles in carbonated water stop rising. They just float in place as buoyancy dies. Oil and water fail to separate without gravity, leading to a strange uniform mixture. Surface air remains dense enough for us to survive for the first few seconds. Sudden temperature drops cause fog to form due to rapid adiabatic gas expansion. Pressure-sealed structures like tires and buildings face immense structural strain during this transition. Pressure-sealed structures like tires and buildings face immense structural strain during this transition. A motorcycle cornering at high speed will simply slide outward when gravity stops. Passengers on a bus feel their inertia take over, drifting against the vehicle's interior. Airplane wings lose lift as the air density thins during the rapid expansion phase. Control surfaces become increasingly ineffective as the aircraft loses its aerodynamic grip on the air. Jet engines fail as the intake air thins, choking the combustion process instantly. Birds suffer total disorientation and cannot fly, losing their instinctual navigation in this state. Wing flapping fails to generate any lift in this zero-gravity, thin air scenario. Our inner ear balance system reacts with panic to the sudden zero-gravity sensation. Blood distribution changes as the gravity-induced pressure on our lower body vanishes suddenly. Joint injuries are a major risk as people try to hold onto fixed objects. Ship propellers lose effectiveness as the water density changes around the hull. Trains on tracks experience no downward pressure, risking derailment as the wheels lose grip. Animals like kangaroos face massive physical impact risks if jumping when gravity hits zero. Small insects struggle as air drag and gravity change their flight dynamics completely. Drones fail as sensors react to the loss of pressure and spatial gravity. Street traffic collisions are inevitable as tire friction fails while kinetic energy remains high. Street traffic collisions are inevitable as tire friction fails while kinetic energy remains high. Accelerometers on smartphones globally will record chaotic, erratic data for these 10 seconds. Wild animals lose their sense of direction, unable to discern which way is down. The moon's gravity persists, but its effect on us is tiny, almost zero, unfortunately. After 10 seconds, a person only drifts about 1.6 millimeters toward the moon. Solar gravity's effect is even smaller, barely impacting us compared to the Earth's spin. Using the formula, we calculate the drift of 0.3 meters toward the Sun. Solar and lunar gravity effects are completely negligible during this short 10-second interval, truly. The Moon's orbit around Earth remains largely undisturbed during this brief gravity lapse. Earth's orbit around the Sun continues, as the solar gravitational bond remains firmly intact. Low Earth orbit satellites drift off course as the Earth's gravitational pull suddenly fails. Geostationary satellites also shift from their positions after 10 seconds of zero gravity. Lunar tidal forces continue to affect the oceans even without Earth's primary gravity. Total gravity on objects opposite the Moon changes at the 0-second mark exactly. Lunar tidal forces are stronger than solar ones, influencing our 10-second phenomenon quite clearly. We compute combined gravitational acceleration from Sun and Moon at noon at the equator. Astronauts on the ISS feel no different during this period, as they are already in freefall. Space debris orbiting Earth drifts away randomly when gravity ceases for 10 short seconds. Earth's magnetic field remains stable, unaffected by the temporary loss of gravitational pull. The Earth's core experiences massive pressure shifts when surface gravity drops to zero momentarily. Earth's orbit deviation is extremely small but measurable by our highly sensitive modern instruments. Light refraction in the atmosphere changes as gas density shifts during this expansion event. ISS astronaut experiences differ from ours on the ground during this 10-second gravity lapse. The 10th second is the most dangerous, as gravity suddenly returns with brutal force. Falling from nearly 2 meters upon gravity's return causes significant impact and injury risks. Billions of tons of ocean water crash down violently when gravity is restored instantly. Infrastructure and skyscrapers suffer structural damage as everything is suddenly slammed back down again. Vehicles floating above the ground are slammed down, causing widespread destruction and vehicle accidents. Fractures and joint injuries will be a global medical crisis after this sudden impact. Water hammer effects across global pipe networks occur when the ocean water rushes back. Pilots face extreme G-force shocks and control issues when gravity suddenly reappears unexpectedly. Imagine shopping when groceries suddenly drift mid-air for 10 long, surreal, physics-defying seconds. Mass hysteria grips the globe as humanity struggles to comprehend this fundamental physical violation. Engineers must design future infrastructure to withstand such potential temporary gravity loss disasters, believe me. A 10-minute gravity loss would be exponentially more destructive than 10 seconds, clearly. Ears and sinuses experience intense pressure changes when the atmosphere recompresses at 10 seconds. The nodes connect here, creating a robust framework. Observe how the information flows smoothly through these interconnected pathways. This concludes our comprehensive summary on the global 10-second zero-gravity event.